Here are your 5 a day, and your answers are here. I just added this part in that this was true. I didn't ask you which one was true and which one was false. I just put. Let me know if you have any questions about them. So today we're going to be looking at the tangent function and how to solve equations involving it and how to sketch transformations of its graph. So if we think about the unit circle and my turn in an anti-clockwise direction from the positive x-axis of an angle theta, this point here, remember the y-coordinate was sine theta and the x-coordinate is cos theta. If I construct a tangent to the circle at the point A, which is 1, 0, it's 1, 0 because it's a unit circle, so it has a radius of 1, then the y-coordinate at C, which is where this line and this tangent cross, well actually this is an extended part of the diameter of the circle, isn't it? But anyway, where they cross, my y-coordinate, which is the point, so C, the point of intersection between the line OP, where O is the origin, and the tangent, this is tan theta. Now, why is it tan theta? From similar triangles, you can see that this triangle here with the green arrows and this triangle, I meant for that to be blue, that triangle that goes all the way across to A and up to C, these are similar because this green arrow and this blue line are parallel, so by corresponding angles, we know that those two angles are equal. These are both right angles, so those two angles are equal, and this angle is common. Because they have 3 identical angles, we know that these two triangles are similar. And so this side divided by this side must be the same as this side divided by this side. So tan theta over 1 equals sine theta over cos theta. And that gives us the identity, really. This should be an identity symbol that has 3 lines, because this is always true, regardless of what theta is. The identity that I spoke about last lesson. So tan theta equals sine theta divided by cos theta. When cos theta equals 0, then tan theta is undefined. So these were the complementary relationships that we had a look at last lesson. And using these properties, we can find some properties of tan as well. So tan of pi minus theta is equal to sine of pi minus theta over cos of pi minus theta. Again, if you want, you can give yourself a quick drawing of the unit circle. Pi minus theta, well, this is pi. So pi minus theta is here. And if you remember with your CAST, your cast diagram, sine is positive in the second quadrant and cos is negative. So this is equal to sine theta over negative cos theta. So that's negative tan theta. Using the same idea, can you copy out each of these statements and write them in terms of ratios of theta? Pause the video while you do that. So you should have, so tan of pi plus theta, that's this one here. We can see that tan is positive in that quadrant. 2 pi minus theta, this one here, tan is negative in that quadrant. Tan of negative theta, that's also this one, it's the same as 2 pi minus theta, so that's negative tan theta. Pi on 2 minus theta, so that's where I'm going to be using these ideas up here, that gives me cos theta over sine theta. Now, there is a way that another thing I can write here, which you may know already. If you don't know it, then we'll be looking at it next lesson. So I'm just going to leave it like that for now. And then tan of pi on 2 plus theta, that's using these two equivalences up here. So we get negative cos theta over sine theta. Now, solving equations involving trigonometry. So you should have had some practice with this in methods. You get some practice with it now in specialist too. So let's start by writing our equation. This 3 is getting in my way on my left-hand side, so I'm going to divide both sides by 3. Now, I need to find what x is, so I need to use inverse tan to get rid of the tan part. But I know that there's going to be multiple, or there might be multiple solutions. I need to know how many of those solutions I need to look for, or in what interval I need to look for them. I'm given my domain here is x is in the interval 0 to 2 pi. I'm going to be solving for 2x, so I need to look for solutions in 0 to 4 pi. I substituted in 2x for x there, so I needed to multiply both of my boundaries by 2. So inverse tan of root 3 on 3 gives me pi on 6. Remember, this is the same as 1 over root 3 if you prefer to think of the value in that way. Then thinking about, so this gives me positive pi on 6. Where is tan next to positive? Well, it's over here, isn't it, in this third quadrant. So I've rotated pi radians to get to here. So I need to add pi onto pi on 6 to get my next solution. And then I'm just going to keep on adding pi, adding pi, adding pi until I get past 4 pi. So if I add another pi onto this, pi is the same as 6 pi on 6. So I get 13 pi on 6. I add another one onto that, I get to 19 pi on 6. Now I've gone round my unit circle twice. That's 4 pi rotations. If I go to the next one, which would be 25 pi on 6, 25 pi on 6 is greater than 4 pi, isn't it? Because 4 pi would be 24 pi on 6. So that's too far, and I've got these 4 solutions. I've solved for 2x, but solving needs to be just for 1x, so I then just need to divide everything by 2. This equation, I've got a couple of things happening to my x. So let's have a look at what we do here. Here's my solution. First step is going to be inverse tan of -1. I need to work out what interval I'm looking in though. Here, I'm between -2 pi and 2 pi inclusive. I need to substitute those into this whole statement here. So my new solutions are going to be then 1/2 times -2 pi minus pi on 4 and 1/2 times 2 pi minus pi on 4. These simplify to these values here. Note that they're inclusive. So now inverse tan of -1 gives me 3 pi on 4. So this would give me positive. So here is my 3 pi on 4. I need to go around to the next place where tan is negative, which is over here. But this gives me, if I add on, that gives me 7 pi on 4. 7 pi on 4 is definitely bigger than 7 pi on 8, so that's too far. So perhaps I need to go back round this way. So remember, this is 0, and I've gone to negative. Oops, it's no good without the circle. And that is the worst circle I have ever drawn. It looks like a rugby ball. So I'm going to negative pi on 4. and that's my next one. If I were to continue going round another pi, that would take me to negative 5 pi on 4, which is the same as negative 10 pi on 8, which is too low for this value here. Then I need to multiply both sides by 2. So x minus pi on 4 equals both of these doubled. Then I'm going to add pi on 4. And in general, we write the solutions in ascending order. You wouldn't be wrong if you didn't, but it just makes it easier to have them organised. Pause the video now while you have a go at questions 1 and 2. Okay, so the graph of tan theta, I want you to pause the video while you copy and complete this table for the graph of tan theta for this domain from negative pi to 3 pi. So you should have got these values. If we think about the graph, here's negative pi, 2 pi, 3 pi. So, oops, that is not where there is an asymptote. This is what happens when you draw a graph too small. We have an asymptote at all of the odd multiples of pi divided by 2. And then our graph goes in between like so. It's inclusive, so we make sure we include our endpoints as solid dots. Okay, the theta axis or x-axis intercepts are at multiples of pi, all integer multiples of pi, and the vertical asymptotes are at odd multiples of pi over 2. So when we're graphing this, we need to make sure we find the period. That's how wide is it before it starts repeating itself. So for this graph of y equals tan theta, it's pi wide. Find the equations of the asymptotes and find the intercepts with the axes. So we need to be able to transform our graphs, and here's a quick reminder of what different transformations do. If I add a value to the x within the function, this gives me a horizontal translation of negative a units. I'm not going to talk now actually, I'll put up the thing, you think to yourself what you think the transformation is, and then I'll put the answer. So let's have a look at using those transformations to sketch this graph here. Let's look at what we have, the transformation. So we've got this negative here multiplying the whole function, so that's a reflection in the x-axis. This is a dilation factor 2 from the x-axis. The word factor is really important when we're describing a transformation, and it's from an axis, not in an axis. Then this 3x gives me a dilation factor 1/3 from the y-axis. My period is the normal period of tan, which is pi, divided by n, which is the coefficient of x. So in this case, the period is going to be pi on 3. And my asymptotes are odd values of, odd multiples of pi divided by 2 times 3, because we've got this third here, so on 6. My axis intercepts are at integer multiples of pi on 3. And so this is what my graph looks like. I've got my endpoints clearly coloured in, and I've got my asymptotes labelled. Have a go at question 3 now. Make sure you mark your work and let me know if you have any questions. Thank you.